So 9. So the curve C has equation y equals fx, alright? Where the first derivative, so f prime x equals x minus 3 and 3x plus 5. Now, I just decided to expand this because, you know, it's just always nice to have a complete looking equation. So expanding this quadratic and tidying up, you should get this result for f prime x. Now, given that the point P lies on C, so remember this is the x and y coordinates, so the only way to really do this is that you need to use the y equals fx. So you need to integrate this. Find fx and simplify in each term. So this is straightforward. To go from f prime x, you need to integrate to have fx. And when I integrate all of this equation here, I got something like, where is it? Over here. So integrating 3x squared minus 4x minus 15, just raise the power by 1 for each one. So this becomes 3x cubed over 3, 4x squared over 2, and this one just has an extra x because there's no term. And don't forget plus c. And I say all that equals fx. And of course, try and simplify. So 3 over 3 cancel out, so these two disappear. 4 cancels out with 2, so it becomes 2x squared. And because we know in the beginning that y equals fx, just replace fx with y. And that's it. And now we say, okay, now we have to try and find the value c. Because when you find the value c, then you've pretty much found the complete fx. And that's why they give you coordinates. The whole point of this coordinate is to plug in to find the actual full equation, not plus c. So anyway, at point P, we just plug in x equals 1 into the equation and y equals 20. And when you do that, just solve for c. Just rearrange this and find c, and you get hopefully 36. And then because it's 36, just write down the full complete equation with 36. That's it. And to me, that's an easy 5 marks. Can't lie, very straightforward. Now, part B. Show that fx equals x minus 3 all squared times x plus a. Okay, so that's literally 2 lots of them, x minus 3 twice, where a is a constant to be found. Now, to find a is actually dead easy, because one thing you have to realize is that this fx is basically the full expanded one we have right here, where we just deduced. And to get the value a, what you have to realize that if you multiply all 3 constants, minus 3 times a, it should give us a result of 36, because if you expand it, that's what happens. So to find a, you just have minus 3 times a is 36. So you get 9. So you got these two gives you 9. So 9a equals 36. Let me write down. Then you just divide by 9 and you should get a equals 4. That's the easy bit. However, sometimes I thought this was a bit too easy. So I realized, and I'm not sure this is 100% guys, you might have to check with me when the actual mark schemes are out, is to actually deduce this expression, how to actually factorize it. So what I did here, I did a little expanding. I said, okay, let fx equal general x plus a, x plus b, times x plus c, just a general way. And then you just have to expand every term. Now, like I said, this could be pointless, but I mean, there's no other way to actually show this. Well, there is. And when you do this, I times the last 2 brackets to get this expression. So x times x is x squared, x times c and x times b gives you this when you collect it, and so on. And you expand the whole lot, basically, all 3 brackets. And you get something like this kind of nasty looking this cubic equation. So basically all we say now is that for the x squared term, we know that if we compare it to the fx function, we can say that a plus b plus c is of course identical to minus 2 because it's the same value. We can say for the x term, all of this is identical to minus 15. And of course the constant term is identical to 36. And then you make an equation. Now, like I said, this is just a method, so I would like to hear your comments on this one. Anyway, that's it really, and you've done that. And C is dead easy. Now part C, how to sketch this curve. Now this cubic curve is very straightforward. Okay, all you have to do is realize that each of these factors are points where you hit the x-axis. For example, x minus 3 means you hit the x-axis at plus 3. So let's assume plus 3 is here. Whereas x plus 4 means you hit the x-axis at negative 4. So let's go back and say minus 4 is here. Now, typically a cubic curve always looks like a snake going from the bottom to the top. So the shape is generally starting from the bottom, you curve down, curve once more and go up. This is a typical positive x cube graph. And you know it's x cubed if you've got 3 factors, or if you multiply the first 3 x's to get x cubed. If you had a negative, if somehow when you expanded this and you had a negative x cube, something like this, the shape would be going downwards, a bit like this, curving up and then finishing down. So remember, positive x cubed, you start from the bottom and you go up. Negative x cubed, you go down and you finish down. Now, because we have two repeated roots, this means that it's going to hit x at 3 twice. So in other words, it's going to bounce off 3. So let's go ahead and sketch this. We're going to get to the y-axis in a second. All you're going to do is start from here, shoot up. Oh man, I missed it already. Go down, and then bounce on this, and then go up. And that's it. You don't necessarily need to draw the arrow, but I'm just doing it for demonstration purposes, yeah? So again, this has to hit at minus 4 and hit it at plus 3. Now, as for the y-axis, I mean, the curve could be, the bending point could be anywhere, so let's not assume that the turning point hits here. To get the y-axis, this is simply when x equals 0. So if you plug in x equals 0 here, you're going to end up having, you know, 0 minus 3 times 0 minus 3 times 0 plus 4. And essentially, what this means is that you can have minus 3 times 4, which will give us 36. And that's it. This is literally all you have to do, guys. So yeah, if you found this video helpful and instructive and, you know, pretty much cover what you need to know, please give me a like, guys. Otherwise, I shall see you next time. Ciao.